On a moonlit night, a group of differing ages has gathered to see science in action. The candle hidden behind the glass jar at the centre of the table illuminates their faces and highlights their different reactions, from anxiety and horror to interested entertainment. The demonstration in Joseph Wright of Derby's An Experiment on a Bird in the Air Pump will show the effects of creating a vacuum and also the necessity of air for all living creatures to survive. The glass vessel which holds the bird is connected to the air pump. As the handle is turned and the air removed, the bird is struggling to breathe. Looking out at us, the scientist, or natural philosopher as he would then have been known, has one hand on the valve which will let the air return. If he turns us in time, the bird may well survive, but it will be changed. Our colleagues at the Science Museum helped us to investigate the science in more detail.
Hi, I am Akvile from the Science Museum in London. Today I have brought an activity that will help you gain a better understanding of the science behind the painting and what's happening to the bird. The demonstration I have is called No Pressure, which is also our learning resource that is available on our website together with many other learning resources. So what we will need today for this demonstration is some marshmallows in a glass bottle, a drink vacuum pump and a rubber stopper. We are going to see what the air pump does when we use it, what is happening to the marshmallows when we use the air pump, and what is happening to the marshmallows when we let the air back in. So to start with, we have some marshmallows inside this bottle. I will put the rubber stopper on top of the bottle and start using the air pump. Take a look at what is happening to these marshmallows. We can compare with another bottle that's filled with marshmallows where the air pump was not used. As we can see, the marshmallows have become bigger. But what happens when we take the rubber stopper off? There we go, it shrinks back to its normal size. But why? Let's start by looking at the science behind this demonstration. The atmosphere stretches above our heads for a few hundred kilometers. The weight of that air presses down on every surface. Trapped inside these small marshmallows are tiny air pockets. The pressure inside this pocket is at atmospheric pressure, which is the same as the air outside. By removing the air, we reduce the air pressure around the marshmallows, so the pressure inside these air pockets, inside the marshmallows, is now greater, which causes them to puff up dramatically. By allowing the air back inside the bottle, the atmospheric pressure presses down on these air pockets inside the marshmallows, which causes them to shrink back to their normal size. Now let's imagine that we did the same experiment again, but instead of marshmallows, we used the bird. What would happen to the bird? It might expand and it might change shape. This happens to humans too. The weight of the atmosphere that surrounds the Earth is pushing down on us all the time. But we don't really think about it because we have evolved to live this way. However, this changes when we go outside the atmosphere into space. For example, the astronaut Scott Kelly grew by 2 inches while he was in space because his spine extended. He's now back to his normal height. Similarly, Robert Thirsk, his eyeballs changed their shape and now he has to wear glasses. His eyesight perhaps is permanently changed. So when we look at the painting, we're really not sure of the fate of this bird. But by doing this activity, we can gain a better understanding of what it might have suffered. This learning resource and other learning resources are available on our Science Museum website.